This is going to be a theorem in this video. It's going to be Theorem 1.019.5, and it says that a tangent line to a circle is perpendicular to the radius drawn to the point of tangency. So what this means picture-wise is that, say we have a circle here and we have some kind of tangent line. If we have a radius going here, it's saying that these are all right angles, or at least they're right angles inside Euclidean geometry. So this is a 90-degree angle. Let's do the proof of this. So we'll say proof. This is going to be a bit of a long one. We'll say let L be a tangent line to a circle we'll say it has center P. So with center P. Let's draw that. So we have some kind of, let's draw a circle first. I think that'll make it easier. Pretend that's a perfect circle drawn, and we have some kind of tangent line here. This is going to be line L. Actually, I'm going to put L at the bottom. I want to draw something else at the top of that. Get to that in a little bit. We'll say let Q be the point of tangency. So we'll have a point Q right here. That's the point where L meets P. Then we'll say suppose L is not perpendicular to the radius PQ. So it's going to be a proof by contradiction. We can say that by a previous theorem, there is a perpendicular from L to P. We'll say let R be the, well, I haven't defined that yet. We'll say let R be the point of, I'm not sure if this is a real word, but we'll say perpendicularity on L. Since this is a proof by contradiction, we're going to do it with a red. We'll do it in red because this can't exist. So going here, this is a right angle. And it looks funny because it can't actually happen. Then we can say that using extendability, we extend, let's see, we'll extend QR past R to a point S such that, let's see, well, we want these two to be equal lengths, so we'll say RQ is equal to RS. Did the drawing a little bit funny, so it's gonna look a little weird here. And we're gonna say that this line, actually we'll do that in a different color. We'll say, let's do it in purple. This length is equal to this length. I haven't drawn to scale, but just pretend that's drawn correctly. I think you'll see what we're going to. Well, then we can say triangle PRQ is congruent to triangle PRS by side angle side. Then by corresponding parts, of congruent triangles, PQ is congruent to PS. Well, then we can say, since PQ is a radius, the point S is on the circle. Well, for a minute I thought we could do that all on one page. We'll go down here just a little bit. So the tangent line L intersects the circle at 2 points. But this is a contradiction because earlier we claimed that by definition of a tangent line, it could only intersect the circle at 1 point. So we'll say this is a contradiction because by definition of a tangent line, it can only intersect at 1 point. I should have wrote it can only intersect the circle at 1 point, but that's not too important. Then we'll say, therefore, L is perpendicular to PQ.